Now we are going to see how do we use the z-interval procedure to compute confidence interval for the mean of a population based on the mean of a simple random sample. So in this example, what you have is that you have 40 applications, which is the sample size. That is, what we mean here is that the sample size, so we have the sample size, which is typically denoted by a small n equals 40, okay, and then we have the mean x bar equals how much, or the sample mean x bar equals how many? 19 minutes, okay, and then we are given the standard deviation, okay, and the standard deviation is 11 minutes, and it says this is the standard deviation for all applicants, that they have this information from some source. So since it says all applicants, this means that we are referring to the standard deviation of the entire population, that is denoted generally by sigma, this small Greek letter sigma. So we have everything that we need to give input to our TI84 calculator. So let's go and work on it. So we are computing the z interval. Why? Because we know the value of sigma. So when we know sigma, okay, so let's look at it. So when we know sigma, we use what? We use the z procedure. Okay, so we use your calculator will call it the z interval. So we'll use the z interval procedure. Okay, if the population is normal, or the population has a normal distribution, or the sample size is large. Here we have a sample of 40 applicants, which we may treat as a large sample. So now we pull up our calculator, go to stat, and then we are going to go to tests, because we are in the territory of inferential calculations. And remember, we are using the z interval. When we do the hypothesis test, that is test for a given value of population mean, in that case we will use the z test, but at this moment we are using the z interval. So we can scroll down, or we can just press 7 directly. Okay, so here we go, and we are using the summary statistics that is given in order to compute it. Now here we have information from a previous calculation, so we can go ahead and overwrite it. All right, so here we are, okay, and just a moment, so I can clear it, and here 11 is the new standard deviation, or in other words, the standard deviation for the question that we are looking at. 19 is the value for the sample mean, 40 is the sample size, and 95% is the confidence level. Okay, so we write all that, and then we are going to ask it to calculate that for us. So when we press enter, then we are going to get this 95% confidence interval for the mean time to review all such applications. Okay, that is, we are 95% confident that the mean time to review all such applications is somewhere in between these two values. Okay, so our answer for this confidence interval is this interval, 15.591 to 22.409 minutes. That is 16 minutes is a possibility, 17.8 minutes is a possibility, because they are all contained in this interval. But if somebody says that it takes, say, half an hour on an average to review all these applications, that will be out of the range. All right. So now let's go ahead and compute another confidence interval for population mean in a different situation. Here we have information about a simple random sample of 40 cars. That is, the mean mileage before showing any major trouble is how much? It's given to be, according to this sample, it's given 37,189 miles, right? And it says that the standard deviation of this sample is how much? Remember, sample standard deviation is generally denoted by small s, okay? So is 6,148 miles, all right? And the sample size here is what? It's 40, right? Now, note there is a difference from the earlier situation. There we knew the population mean, that was denoted by what? Sigma, right? But here we do not know the population mean, okay? And again, we will work under the assumption that we have a normally distributed population, or if the sample size is large, we can still go ahead and work. So anyways, here the difference is that we know the sample standard deviation. To get a more conservative estimate this time, it is a good idea to use a t interval instead of a z interval. All right, so here is a t test, and the t test is for, again, testing a given value of population mean. So let's just scroll down and look for t interval. It's right here, okay? So we press enter, all right? And again, we are using summary statistics only, okay? So we will say, well, that our calculation is based on summary statistics, and we will go ahead and enter the values that we have. So the sample mean is 37,189 miles, and the sample standard deviation is 6,148. Sample size is 40, and the confidence level in this case is also 95%. So we will go ahead and ask it to calculate the interval for us. So when we press enter, we are going to get the answer for the interval for the mileage before any major trouble for such cars in this situation. And the interval obtained is, so the mean miles for all such cars is somewhere in between these two values, and that we can say with a 95% confidence, okay? So just for practice, let's work on another such computation, okay? And we will go a little faster this time. That again, we have to compute a 95% confidence interval for mean expenses for all these students on books and supplies, okay? And here we are given that sigma, the population standard deviation, is 132.5. So since we know it is sigma and we are computing confidence interval for population mean, which procedure shall we use? We shall use our z interval procedure, right? Okay, because we know the population standard deviation sigma, and even when you go there to input the data, it does ask for sigma, so we have to know sigma to use this procedure, okay? So what we do is we will go ahead and enter the values in here, okay? And then the mean, the sample mean is how much? 397.63, and the sample size is 35 and the confidence level still is 95%. I mean, that will not always be the case, but often people use this confidence level, but we can change the confidence level if needed for our calculations. Okay. So as before, all we have to do is to press enter, and here we have the desired confidence interval. Okay. Now here we have to construct a 95% confidence interval. Okay, for the mean blood sugar level, fasting blood sugar level for this person in milligrams of deciliters, okay, or per deciliter. Now here the difference is that we are working with raw data. So how many items are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a small sample, and what we do in such cases is this, that we look at a box plot or some other appropriate diagram to see if the data has any strong outliers, because if we have real big departure from normality, then this procedure for computing the confidence interval might be misleading. So now here we do not know the population standard deviation, and all we have to work with is the sample data, and in addition the data is simply it's a raw data. We don't even have the summary statistics. Okay, so what we will do now is, as before, we will go to stat tests, and of course we are using t interval because we do not know the population standard deviation. Okay, and instead of stats, in this case what we are going to have to do, we have to use data. Okay, now it's asking us where the data is. Okay, so we have the data. We are going to put the data in the list L1. We can change that if we want, but let's put that in L1. So for that what we will do, we will go and edit the list of data, and in L1 we already see some data. So what we would do is, let's scroll up, highlight L1, press clear, okay, and then simply press enter. All that is gone. So now we will do this, that one by one, okay, we shall enter all the values, and be careful that we don't make any printing mistakes. And I have to be careful because I'm simply talking to the monitor, not a live class in front of me. So anyways, so let me finish it and come back to you. So now that I have entered all the data points, all 10 of them, okay, so they are all entered here. So what we would do now is we'll go back to stat, go to tests, okay, and then scroll down until we get to the t interval, or just press 8 on your key. Oh, I went too far. So we could have just pressed 8. Okay, so we are looking at t interval. All right, and we are obtaining it from raw data, and the data is in the list named L1. Frequency is 1, means that every number entered there has a frequency of 1. In case you want to make a frequency table, okay, that in that case you have to list the frequencies in another list, but in this tiny calculator we are not going to do any more than this. And confidence level still is 0.95, changeable though. Okay, and then we will say calculate. Okay, and then press enter, and as before, the overall mean for this person is 83.585 mgdl2 85.815 mgdl. Okay, and that's what we can say with a 95% confidence. Now let us revisit the example number 1 of our calculations, okay, in this discussion. That is, we used a TI84 calculator to compute a confidence interval when the sample mean was obtained to be 19 minutes and the population standard deviation was 11 and the sample size was 40. So we got this as our answer, and this is the confidence interval means what? That the population mean is anywhere in between these range of values. And how did we get these range of values? We use the sample estimate 19 as an estimate for the population mean, and then this whole range was obtained by that give and take factor, which in other words can be called the margin of error of our estimate. Now, so this distance here is the margin of error of this estimate, and we can compute it by simply doing the following. That is, just take the right end point, sorry about that, okay, here, sorry. So we have 22.409, and if we subtract 19 from it, the margin of error of the estimate is what? 3.41 minutes approximately. Or even if we do the other way around, that is subtract the left end point from the center value, okay, which is 15.591, we will still have the same value. Okay, so what we got here, that this distance is 3.409 minutes, okay, margin of error. Or even if we go ahead and look at it this way, okay, this will still have the same value, that is 3.409 minutes. Okay, so now say we do not have a calculator like TI84. Okay, a calculator these days is very useful, I mean at least a basic calculator, but anyways, so, and we still are computing the confidence interval for this example where we are given the sample size, the sample mean is given, and population standard deviation is given. So in this case what we can do is, if you read the lecture notes, okay, we can use this equation to obtain the margin of error where sigma is 11 and n is 40. Once we get the margin of error, we will combine the margin of error with our point estimate, that is the sample mean that is given here. Okay, so let's go for that calculation. And what is Z star? Z star is the critical Z value for a 95% confidence interval, which if you are not using calculator, you can obtain in the following manner. So remember, I created a list of tables for you that I have posted here. So just click on the tables. Now go to page 3. So here you can see you have 95% confidence interval level given. And if you go to the bottom, you'll see the Z star and corresponding to 95% confidence level. You know, this column corresponds to that. The Z star is how much? 1.96. So from the table we obtained Z star equals how much? 1.96. Let me change color of this font, 1 second. Okay, so we obtained it as 1.96. Now you can use your calculator also to obtain this value. I'll go on that in a moment. Okay, but first just let's look at this. So Z star is 1.96, sigma is 11, and the sample size is how much? 40. So if we again take this equation and substitute these values in here, that is 1.96, right, times the population standard deviation, okay, which is 11, right? Then we divide it by what? The square root of n equals how much in this case? N equals 40. Okay, so let's bring 40 in here. Okay, and stretch the square root just to make sure that we don't make any mistake in computation. So if you compute this value by your calculator, you will find that m is 3.409 minutes approximately, and you can use that to write a confidence interval. One moment. Okay, and the confidence interval can be obtained by just take the estimate, subtract the margin of error, all right, and then again take the estimate and add the margin of error, okay, and that will finally be, so we have 15.5912 to 22.409 in minutes for the confidence interval, for a 95% confidence interval for the population mean in this scenario. Now, just to show you that you can obtain Z star with TI84 as well, you don't necessarily use need a table, and you choose whatever you would like when you're working on it. Okay, so let's go ahead and say compute this Z star. Say compute means obtain. Calculator is doing the computation. So say we want it for 95% confidence interval. Okay, so I'm going to show you how to obtain that. Okay, so when we talk about Z star is a particular value of this standard normal distribution whose mean is 0 and the standard deviation is 1, and it is such that the area between the standard normal curve between negative Z star and Z star is how much for this interval? 0.95. Okay, now your calculator can give you percentiles of a normal distribution if you input in the calculator the cumulative area to the left. Now notice the middle is 0.95, so these two tails are going to share how much? 1 minus 0.95, that is 0.05. That is, the total of these two tails will have an area of 0.05. So each of the tails will have area of half of 0.05, and what I mean to say is that this area right here will be 0.025. That means Z star is a value such that 0.95 plus 0.025, that is 0.975 or 97.5% of the area is to the left of this Z star, and you can obtain this value by using the inverse norm. Okay, and we go to inverse norm, and our input would be what? 0.975, because that's the percentile that we want. And you may put 0, 1, and to be conservative, doesn't hurt, only a few seconds to put it. Even if you don't, by default it will go to standard normal distribution. So what you have here is 1.96 is approximately the critical value as suggested by the table 2 digits after the decimal sign. Okay, so we went through that procedure to work on different kind of question. That is, here we have to construct a confidence interval. Okay, and we have not taken any sample yet. Okay, Now, so here we want to determine the required sample size. If you are reading here, you can see it says how large a sample must be taken, okay, so that we can construct a confidence interval for estimating the population mean with a margin of error of no more than 25 points. So earlier we used to compute the margin of error, but here we have a desired margin of error, like to the level of accuracy that we want in our calculation, and we are given the population standard deviation, okay, and then we are given the confidence levels, the levels at which they want the answers, okay. So in this case, what we have margin of error, we have population standard deviation, and we have the confidence level, and we have to obtain the sample size. So here we have, again, we know the margin of error z star and sigma, and we have to obtain n. So what it simply means is, let's keep things handy. First, let's just go ahead and solve for n so that we can work with that for all our questions. So we got this equation, right? Okay, and we have to solve for n. Now the equation has fractions, so a good strategy, as you know, is to multiply both the sides by the lowest common denominator. So in this case, the lowest common denominator is square root of n. So when we multiply, on the left hand side we will have square root of n multiplied with m, and on the right hand side square root of n will cancel. Now we have to isolate square root of m. So let's isolate it. Okay, so we got this, and then here we have z star sigma divided by how much? M. So if we want to obtain our n, what we will have is that we will simply square this quantity. All right. Okay, so one moment. So this will be our equation that we are going to use to determine the required sample size for our calculation. So let's take it back into our question. Okay, so now here we have to obtain n, where sigma is given to be 175, margin of error is 25 at these three different confidence levels. So these will be the same. The only thing that will change is the z star at these three confidence levels. So why don't we go ahead and write the values of z star for these three confidence levels here. So you can obtain from this table that for 90% level, our z star is, so 90%, z star is 1.645, right? And for 95%, it's 1.96. 95% z star is 1.96, and for 99% it is how much? Well, we go all the way down here, it's about 2.576. So we will use these values in our calculations. So now to obtain these values of n, we obtain these from the table, or we can use the calculator to obtain that. All we have to do is substitute the appropriate values at these three levels. So what we have is, let's take our equation and use it one by one for all three of these. So here what we got simply, let me write it here and then I'll take it in there, 645, okay, and times was the standard deviation 25, okay, so that goes in here, okay, no, sorry, that was 175, okay, made a mistake. Okay, so let me write it down. 175, and here we are. So we have this as our numerator in here, and what do we have in the denominator? In the denominator we will have simply 25. Okay, and we can use any simple calculator to obtain these quantities. And now we will fill out the values for these two in the similar manner. And these values can be computed by any calculator, but since we have this calculator, let's just use this one. So what we do for this, we have 1.645, okay, times 175 divided by 25. I mean, we know 175 over 25 is 7, but anyways, okay. Then we square the quantity. So what do we get here? 132.595, or 133 is the required sample size, because that will have to be a whole number. So here our sample size is what? We need a sample of size 133, and that will be our answer in this case. Okay, for the other one, let's go forward and then again just write the numbers in. So we have 1.96 times let me write 7, because we know that 175 times 25 is 7. That will save us a little time. Okay, so here we have 188.2384. Now we are writing the sample size as whole number, and here in a way it says that we need at least these many. So for such cases we will always round up, and then in this case, what is the sample size? 189. Let's compute the last one as well. I'll go ahead and clear it now. Here, so we have 2.576, okay, times 175 over 25 again is 7, and then we will square. Oops, sorry, I made a mistake. Let me just rewrite it. I just pressed the enter key too soon. Okay, 576. Don't do that on the test. So we have 7, and then we got squared. Okay, and what do we get? 325.15, and again rounding it up will give me 326 as the required sample size in this case. Okay, so now we are computing a confidence interval for a population proportion. So for instance, if we have this example in which a simple random sample of 431 people are contacted, and 329 of them have said yes on a certain question, then we want to know a confidence interval for proportion of all the people at 95% who would say yes to such proposal. Okay, so what we do here is this, that is we will go to again stat, we want test, and now we want one proportion z interval, and that's all that we are going to use in this particular course. Okay, all right, so here is one proportion z interval. That's the option that we are going to choose, so press enter. All right, now x is the number of favorable responses, which in this case would be 329, and then n is the total number in the sample, which in this case would be 431, and confidence level, well, we have it at 95%, so we can leave it there, and then we just have to say calculate. So we press enter for calculate, and the confidence interval for the population proportion is what? 0.72321 to 0.80347, or in other words 72.321% to 80.347% if we want to change the proportion to percentage. Now let's look at the last example in this round, okay, because there are many examples like this in the list of practice exercises that you have. So say we are looking at this simple random sample of 821 people, okay, and 63% of them approve the performance of a new president. And we want to construct a 95% confidence interval for the proportion of all the people who approve the president's performance. So we can, we can go in the same manner, all right, but the thing here is this, that is, if you recall that for one proportion confidence interval, the input that we need is x and n. Here we don't have x, rather they gave us 63%. So the first thing that we have to do is we have to compute x, and x would be what? 63% of 821, which is going to be approximately, I just wrote approximately, haven't calculated it yet. So say we have this here, 0.63 to compute the 63% of 821, okay, and that's approximately how much? Say 517, okay, so that is 517. So that's what our x will be in this case, and n is how much? 821. So we go to stat and we just go to our previous option from the menu that is given, okay, all right. So here is one proportion z interval, and we have our x as 517 and n is 821, and confidence level is 95%. So let's go ahead and calculate it, or let the calculator calculate it. So press enter, and here is our confidence interval. Now let's work a little further. So the estimate from the sample was given to us as 0.63%, or p hat is 0.63 as indicated by calculator also. So if we want the margin of error, what we have to do is just take the point estimate which goes in the middle, and either simply do this, that is take any of the points, say the right end point. What is the right end point? 628, and then subtract what? 0.63 from in here. And what is the margin of error? The margin of error is 0.0328 or 3.28%. They did not ask us to compute it, but we are computing it anyways. So the margin of error turns out to be how much? Let me just write it again for you. 6628 minus 0.63, which will be 0.0328 or 3.28%. Okay. Now notice in the next part they are asking this, that if we wanted the margin of error to be no more than 2 percentage points and the confidence level is still the same, how large a simple random sample should be taken. Okay, so here the calculation will go very much similarly along the lines of the population mean, okay, but with some different style. Okay, so here in the second part we have to determine the sample size for a margin of error of no more than 2% or 0.02 points, right? Okay, so if we just go ahead and do same kind of equation solving for the equation for, or the formula for margin of error for proportions, we arrive at this conclusion that this desired sample size will be determined by n, whereas before Z star is the critical value of Z, which at 95% level, it would be how much? 1.96, as we did a short while ago. M is the margin of error, which is 0.02, and for P star, we can use 0.63 because, that's what a previous sample stated. Or some people, to go towards more conservative side, they choose the, side of the interval that's closer to 0.5, but let's go in a typical manner. Let's go with 0.63 here. So what we will have is that we shall just go ahead and substitute the values here. Okay, and I'm going to just expand this a little to accommodate all our numbers. Okay, all right. So what we have in here is that let me just first make the line here, and in the top we have the Z star, that's 1.96. In the denominator we have 0.02. Okay, and then for the other portion we decided to use 0.63, the proportion from the previous part, so that is 0.63 times 1 minus 0.63, and all I have to do is that put that in my calculator, which we will write here. Okay, so we got 1.96 divided by 0.02. Okay, and then we square the quantity, then we multiply by 0.63, and then take 1 minus 0.63. All right, and we have what? 2238.69, or rounding will give us 2239 as the required sample size. Now I illustrated these many. If you have more questions or you want me to write more exercises to practice this, let me know. Okay, hope it clarifies the idea a little much further.